Hello students, we are going to study the chapter hydrogen. Okay, when I say hydrogen, its symbol is H, isn't it? Consisting of how many electrons? One, isn't it? One electron, one proton. It has got isotopes also. Okay, and accordingly it will be consisting of neutrons. Okay, this hydrogen, okay, is the third most abundant element on earth. Okay, and yes, we are trying to use this hydrogen as our future energy. Okay, now if we talk about hydrogen, where it is placed in the modern periodic table, okay, we see that yes, no group has been allotted to hydrogen. Okay, if you see your NCERT book, okay, it is kept above this lithium in first group, but you will see that there is some space between hydrogen and lithium in the book. Okay, why? Because it is not in group 1. Group has not been assigned to hydrogen, even though it belongs to period 1, but it doesn't belong to group 1. No group has been assigned to hydrogen. Why? Because this hydrogen resembles the alkali metals which are present in group 1 as well as the halogens which is present in group 17. Now how? There are number of properties of hydrogen which suggest that yes, it can be kept in group 1 also and can be kept in group 17 also. Okay, so there are number of characteristics which it will resemble with the alkali metals as well as the halogens. So those characteristic features we are going to study. See, first it resembles alkali metals, we are saying. Why? Because its electronic configuration, if we see, of hydrogen. Hydrogen consists of only one electron. So it's this electronic configuration becomes 1s1. Okay. If we talk about lithium, its atomic number is 3. It becomes 1s2, 2s1. So you can see its electronic configuration in the last, it is having what? Only one electron. Okay, and that too belongs to the s block. Okay, so 1s1, 2s1, electronic configuration similar. Now coming to the electropositive character, this hydrogen can give one electron. Okay, this can give one electron to become H plus ion. Okay, here you can see lithium belonging to the alkali metals can also give one electron to give Li plus. Okay, like that we can do of sodium also. Na gives one electron to give Na plus. Okay, now oxidation state, when we see majority this hydrogen, it shows what? Plus 1 oxidation state. Sodium also shows plus 1 oxidation state, isn't it? All belonging to the alkali metals only, isn't it? So here you can see the oxidation state is also similar for the hydrogen and the alkali metals. Now reaction with electronegative element. Okay, now you can see hydrogen can react with chlorine to give HCl. Okay, sodium can also react with chlorine to give NaCl. Okay, getting? Likewise, hydrogen can react with oxygen to give H2O. Okay, here sodium can react with oxygen to give Na2O. So you are seeing similar reactions. Okay, in case of hydrogen as well as the alkali metal. Now coming to liberation at cathode, okay, this hydrogen is also in the process of electrolysis. Hydrogen is liberated at cathode, okay. Other alkali metals are also liberated at cathode. For example, if you take HCl, okay, you are taking what? HCl, okay, electrolysis, okay, you will get H2 plus Cl2, okay. So here H2 will be deposited at cathode and Cl2 at anode. Likewise, if we see sodium chloride, if we are taking NaCl, okay, electrolysis, okay, you will be getting Na at cathode and Cl2 at anode, okay. So you can see here the deposition of sodium also at cathode, okay, it is a alkali metal, and hydrogen also at the cathode. Now this hydrogen has got reducing nature. Come on, take some example like Fe2O3, okay, plus H2. It gives Fe plus H2O. You can balance the equation, you will be getting. Okay. Now how hydrogen resembles the halogens. Okay. When we talk about the valency of the hydrogen, it is 1. Halogen also it is 1. So both are having the valency of 1. Actually what happens over here? Hydrogen, what happens in this? It has got 1 electron in its outermost shell. If it takes 1 electron, it becomes stable. Halogens also have got 7 electrons in its outermost shell. And if it takes 1 electron, it becomes stable. So the valency, the combining capacity is what? 1 for both the halogens as well as the hydrogen. Okay. In the case of alkali metals also we saw valency 1 for both alkali metals and the hydrogen. Okay. But the difference was there, what? That in alkali metals, when it is resembling alkali metal, it is giving 1 electron to become stable. While when it is resembling halogens, it is taking 1 electron to become stable. Okay? Now, electronegative nature it has got this hydrogen and halogens. Okay? How hydrogen accepts 1 electron. Okay? And it can become H minus. Okay? And here chlorine, if we are taking a halogen like chlorine, it accepts 1 electron and becomes Cl minus. Okay. So when we talk about the oxidation state, it becomes minus 1. Okay. Like you can take the example of any for example, if you are taking oxidation of minus 1 like NaH, okay, N will have a positive side, H minus. Okay, like that if you are taking this NaCl, Na plus Cl minus. So having the oxidation state of minus 1. Now we see that yes, hydrogen can be liberated at anode as halogens are also liberated at anode. Like if we are taking NaH, sodium hydride, okay, electrolysis. Okay, what happens over here? It gives Na plus Na and it gives H2. Okay, this H2 is at anode and this Na is at cathode. Okay. Now, if we take NaCl, electrolysis, okay, you are getting Na plus Cl2, that is at anode, and this is at cathode. So we see from here that yes, both hydrogen as well as the halogens we can get at anode. It can be liberated at anode. Now, when we talk about the atomicity, okay, hydrogen exists in the form of H2, isn't it? Chlorine also exists in the form of Cl2. Bromine also exists in the form of Br2. Okay. Now, here, reaction with the metals. Hydrogen, Na plus H2 gives NaH. Okay. And here you will be seeing Na plus Cl2 gives NaCl. Okay. So you can see here it combines with the metals to give the corresponding product. Now formation of covalent bond. Okay, hydrogen and halogens both forms covalent bond. For example, methane, if we take CH4, it has got water. Covalent bond, isn't it? It forms covalent bond. If we are taking CCl4, it is also having a covalent bond, isn't it? So basically they form, both of them forms covalent bond. So here we can see that yes, this hydrogen resembles this halogens also and alkali metals also. So how can we place it in particularly in alkalis or with the halogens? Okay, so it is kept separately in the periodic table, not in any group. Okay, but yes, this hydrogen belongs to period 1. We have studied that yes, this hydrogen behaves like the alkali metals and behaves as the halogens. Okay, so it can't be kept in alkali metals or halogens, it is kept separately in the modern periodic table. There are number of properties also, okay, which is different and which allows hydrogen to be placed separately in the modern periodic table. So what are those typical properties of hydrogens? Let's just see it, okay. Like this hydrogen, okay, it does not behave like metals at ordinary temperature and pressure, okay. Alkalis behaves like metals, but this hydrogen does not. It requires high temperature and high pressure to behave like a metal. So here it is not obeying or not having the properties like the alkali metals. Now, oxidation state, it is having +1 also like alkali metals. It is having -1 also. Like I said to you, it can give 1 electron to become stable or it can take 1 electron to become stable. So oxidation state both +1 and -1. Where to keep? Isn't it? Now, here water, this when we see this oxide of hydrogen, okay, it is amphoteric in nature. It behaves as the acidic behavior also it has got, basic behavior also it has got. But when we talk about the halogens, their oxides, they behave as water, acidic in nature, and oxides of the alkali metals, it behaves as basic in nature. So here also there is a difference, isn't it? Now, when we see this hydrogen, okay, it exists in the form of H2 molecule, okay. So it doesn't have any extra lone pair of electrons in it, but halogens does have. So here it can't be kept in halogen, only in the alkali metal. So in this it can be placed in halogen, not in alkali metals, not resembling the alkali metals, okay. When we talk about the ionization energy, now here we are seeing the ionization energy comparable to the alkali metals. It requires too much of ionization energy. So it can't be kept in alkali metals also, because here it is not behaving like alkali metals, okay. And when we talk about the alkali metals, they mainly form the ionic bonds, but when we see hydrogen, it mainly have covalent bond. So somewhere it is resembling the halogens, somewhere it is resembling the alkali metals, which makes it totally different and can't be placed with alkali metals or the halogens, and is kept separately in the periodic table. Okay. Now, talking about the isotopes of hydrogen. Okay, there are three. Okay, protium, deuterium and tritium. Okay, protium symbol is H, deuterium symbol is D, tritium symbol is T. Okay, we can see atomic mass of protium. Protium is 1, deuterium is 2 and tritium is 3. Atomic number similar because isotopes are those, okay, which has got similar atomic number but different atomic mass. Okay, so here you can see, if we talk about the number of electrons and number of protons and number of neutrons in different this isotopes of what hydrogen. So if we are talking about protium, number of electron is 1. If we are talking about deuterium, it is 1. Tritium, it is 1, isn't it? Now protium, if we talk about the proton, that is also 1, isn't it? For all, because atomic number is similar. Now what about the neutron? In protium, neutron is not present. So neutron is absent. Now deuterium, you will see how many number of neutrons is present? 1. And in case of tritium, how many number of neutrons are present? 2. So we can see that yes, there is difference in the number of neutrons present in all the three, where protium we see that neutrons are totally lacking, but deuterium has got 1 neutron and tritium has got 2 neutrons. Okay, so these are the isotopes, and accordingly, according to the atomic mass, you can see, we can compare it at how heavy it is. Okay. Now let us study preparation of dihydrogen, that is H2, okay, and we call it as what? Dihydrogen. Okay. Okay. Now, so preparing of this dihydrogen or H2 can be done by lab method, commercial method and different methods. Okay. When we talk about the lab method, it means we are making pure form of this hydrogen, dihydrogen. Okay. So how can we prepare? A simple example you have studied in class 10. Okay, like when we are taking Zn granules in a test tube and we are adding H2SO4, what happens? This H2 gas is liberated. Okay. How we test the presence of this H2 gas? By taking a burning sprinter, okay, near the gas, okay, and it burns off with a pop sound. Okay, so it reacts with H2SO4 to give what? ZnSO4 and H2, and this H2SO4 is an acid. So here we are seeing reaction with the acid. Now let us see the reaction with alkali. We will be getting hydrogen gas in that also. So alkali, best example you can take of NaOH. Okay, so when you are reacting zinc with NaOH, you are getting what? Sodium zincate, that is Na2ZnO2. Okay, plus what you are getting? Hydrogen. So here in this we can see that this hydrogen which has been liberated, okay, this is totally pure, okay, here and here pure and in small quantity. In lab only small quantities are prepared. Now let us study about the commercial preparation of hydrogen. Okay, commercial preparation means, it means we are producing or we are making hydrogen in larger amount. Okay, so for large amount, what happens here? In this we take what, or we do electrolysis of water. Okay, so electrolysis of water we are doing and we will be getting H2 and O2. But yes, keep in mind that here we are taking traces of H plus or OH minus ion. It means we are taking traces of acid or a base. So what is the importance of taking H plus and OH minus over here? Okay, or the traces of acid or a base. Actually what happens, this H2O, it is very weakly ionized to H plus and OH minus ions. Okay, and thus we will be saying that yes, it is a bad conductor of electricity. Reaction to proceed. Okay, what happens if we add traces of acid or a base? What happens? It increases its electrolytic power. Okay, and as the result, it increases the formation of the ions, thereby facilitating the electrolysis process, okay, to continue and to form H2 and O2. Okay, now we get hydrogen as a byproduct from this Nelson or Kassner-Kellner cell. Okay, actually in this NaOH and chlorine is being prepared, but as a byproduct we get hydrogen. So let us see the reactions. Okay, sodium brine solution is the aqueous solution of NaCl. Okay, breaks up into Na plus and Cl minus ions. Okay, so here we can see in the cathode, we can see the reaction. This water takes the two electrons, forming what? Hydrogen and 2 OH minus ions, and at anode we see what? This chlorine 2 Cl minus ion gives this 2 electrons, which is taken up by the water, and here we see sodium taking 2 electrons, becoming sodium atom. Okay, so here the overall reaction we see Na plus Cl minus plus H2O gives Cl2H2 plus 2Na plus OH minus ion. So along with this NaOH and Cl2, we are getting this hydrogen gas. Okay, next method is by the reaction of steam on hydrocarbons. So what are hydrocarbons? Actually compounds of carbon and hydrogen, isn't it? Formula of the alkane is what? CnH2n plus 2, isn't it? For alkene it is CnH2n, isn't it? And for alkyne it is CnH2n minus 2. Okay, so here we are seeing what? Here we have taken an alkane CnH2n plus 2, okay, and we have added water to it. Okay, number has not been fixed because this is a general reaction. Okay, the temperature here we are taking too high, and that is 1270 Kelvin. Okay, and taking a catalyst, that is nickel, we are getting what? CO, that is carbon monoxide plus 2n plus 1. Okay, H2, it depends upon the number of N taken. So this is a general formula. So we get what? Carbon monoxide plus hydrogen mixture known as what? Water gas. Okay, this water gas is also known as synthesis gas. Why? Because it is used in the synthesis of methanol, that is CH3OH. Okay, and it is also known as syngas. Here we have seen a general equation of the preparation of hydrogen by steam on hydrocarbon. Now we are taking a specific reaction, like if we take methane, okay, and we add water to it, taking temperature 1270 Kelvin and taking the catalyst nickel, we get CO plus H2, which is commonly known as water gas. Now let us study about the preparation of syngas. Okay, so syngas, we all know what is syngas. It is CO plus H2, isn't it? So how can it be prepared? It can also be prepared by scrap or the wood, or from sewage also we can prepare the syngas. Okay, when this syngas is prepared from coal, it is known as coal gasification. Okay, now here actually what happens, let us study. Okay, see, carbon, coal, coke, anything, okay, with water, high temperature as high as 1270 Kelvin, taking nickel as the catalyst, we are getting carbon monoxide and hydrogen. Okay, so we have got the water gas over here. Okay, now this production of this hydrogen which you are seeing over here, okay, it has been produced when coal has reacted with water at a temperature of 1270 Kelvin in the presence of the catalyst nickel. Okay, now we want more of hydrogen. So we can take this carbon monoxide which has been prepared, and we can again add water to it. Okay, and when we are adding water to it at temperature 673 Kelvin, and yes, we are taking a catalyst over here, that is iron chromate. Okay, we are getting what? Carbon dioxide and hydrogen. So you can see again we have got hydrogen over here. Okay, so if here the production of hydrogen has been increased, isn't it? You can see from here to here, from this CO only we have got again hydrogen. Okay, and this carbon dioxide which we have got can be removed by scrubbing it with this arsenic, okay, solution, sodium arsenic solution, and by passing it, the mixture through a water at 30 atmospheric pressure, this carbon dioxide can be removed and we will be getting hydrogen gas. So here actually we are seeing this reaction is only just taken forward, okay, and then we are getting hydrogen. So here we are saying this reaction as water gas shift reaction. Okay, so let us study about the physical properties of hydrogen. Okay, when we see this hydrogen, actually it is colorless, no smell comes out, isn't it? So this we can observe during the experiment of this zinc plus H2SO4 hydrogen gas is liberated. We don't see that it has got any color or it has got any smell, and yes, it doesn't have any taste also. Okay, now it is highly combustible in nature. Okay, totally it reacts and it catches even fire. Okay, tremendous amount of energy is released. Okay, it is neutral towards the liquid, so it is neither acidic nor basic in nature. Okay, now if we talk about this hydrogen occurs in a diatomic form. Why? Because it has got one electron in its valence shell. It reacts with hydrogen itself to form what? H2 molecule, so it becomes diatomic in nature. Okay, and yes, this hydrogen gas can be liquefied if we lower the temperature and if we make the pressure high, then this gas can be liquefied and we can get liquid hydrogen. Now let us study about the chemical properties. Okay, so regarding chemical properties, when I say, it means what? How it is reacting with the different substances. Okay, so yes, if we want this H2 molecule, okay, to break into atoms, okay, we have to apply too much of energy to it because we are disturbing its stability, isn't it? So we have to apply too much of temperature, that is 500 Kelvin. If we apply, it can be broken down into 2 atoms of hydrogen. Okay, this hydrogen, okay, this reacts with the halogens. Halogens are represented by letter X. Okay, so it is reacting with X. Okay, and X can be what? Fluorine, chlorine, bromine, iodine. Okay, and can form what? HX. Okay, it means it is forming a halide. Okay, hydrogen halide, that is what? 2HX formula. Like for example, if it is reacting with chlorine, okay, so it will form what? HCl, 2 molecules of HCl or 2 moles of HCl. Okay, now it reacts with oxygen, okay, to form water. You all know, yes, tremendous amount of heat we have to supply, and yes, we have to use the catalyst. It forms what? Water. With nitrogen we see it forms NH3, that is ammonia. Okay, actually here conditions required are 673 Kelvin temperature, 200 atmospheric pressure, and we use iron as a catalyst. We get water, ammonia, that is 2 moles of NH3. Okay, and this is also known as what? Haber process. Okay, now this hydrogen reacts with this alkali metals, okay, and naturally it forms the corresponding hydride. Okay, here we can see that this alkali metals gives electrons to hydrogen, and hydrogen accept the electron. Okay, ionic bond is being formed, and having the formula, that is MH, you can, if it reacts with suppose sodium, it forms what? NaH, that is sodium hydride. Okay, when this hydrogen, okay, react with any metallic ion like M2 plus, or you can even write PD2 plus ions, okay. So naturally it will form what? PD, that is lead, and 2H plus ions will be released, okay. Now when it reacts with metal oxides, okay, any metal oxide you can take, like CuO, okay, copper oxide, okay. This copper in the reactivity series, it comes below hydrogen, okay. So naturally what will happen, this hydrogen will reduce this copper oxide, because here hydrogen is more reactive than copper, okay. So it will form what? Copper, Cu, okay, and plus H2O. So here you will be seeing this metallic oxide, the metal is been reduced, which reacts with hydrogen. As these metals which is being reacted with H2, it comes below the reactivity series. In place of copper oxide you can take lead also, you can take silver also, okay. Now this hydrogen reacts with aldehydes, okay, to form what? Alcohol. It forms alcohol, okay. So here hydrogen reacts with an aldehyde to form an alcohol, okay. Now hydrogenation reaction, okay, actually what happens in this hydrogenation reaction, any alkene or alkyne, okay, reacts with hydrogen to form what? The alkane. So it reacts with unsaturated hydrocarbons, okay, in the presence of nickel, platinum or palladium as catalyst. Taking temperature 473 Kelvin, we get what? A saturated hydrocarbon. And yes, in the hydrogenation reaction, this vegetable oil is being converted into vegetable ghee. So this is all about the chemical properties of hydrogen. So today we have studied about this hydrogen, with what does it resemble, alkali and alkaline, alkali metals or halogens, where it should be placed, and its properties, its preparation. Okay, hope you might have understood it. Good day, take care.